Okay, so welcome to my video on binomial distribution. And it's really important to know that this method of probability is only possible if there is two outcomes. So what do I mean by this? An easy example would be flipping a coin 5 times. When you flip a coin, there's only two possible outcomes. It's either going to be heads or it's going to be tails. So it is possible to use the binomial distribution to solve the probability of how many of those 5 coin tosses are heads and how many are tails. And I'm going to talk about this a little bit more in this example. Just remember that this method is only possible when there are two outcomes. So let's get started right away with this example. Okay, in this example it says a student guesses on all 5 questions of a multiple choice quiz. Each question has 4 possible answers, and it's asking us what is the probability that the student got exactly 4 questions correct. Now, it's important to recognize that there's only 2 possible outcomes for this problem. One of the outcomes is that the student is going to get the question correct, and the other outcome is that the student is not going to get the question correct. So since there's 2 possible outcomes, we can solve this problem using binomial distribution. Okay, so let's write down everything that we know. In the first line it says a student guesses on all 5 questions of the quiz. So the total number of guesses, or the total number of trials, which we're going to write with the letter n, we know that the total number of trials is equal to 5. Okay, and this question is asking us what is the probability that the student got exactly 4 questions correct. So out of the 5 total guesses, he's going to succeed 4 times. He's going to get 4 questions correct. So the number of times he succeeds, which is the letter k, is equal to 4. So we know if there's 5 total questions on the quiz and the student got 4 correct, that means that he must have got 1 incorrect. And we can write the number that he got incorrect, or the failures, with the letters n minus k. The total number n, which is 5, minus the number right, k, 4, 5 minus 4 is equal to 1. So now let's talk about the probability of success, or you could say the probability that a student gets a question correct. It says in the problem that each question has 4 possible answers, and only 1 out of those 4 answers is the correct answer. So if the student guesses, there's only a 1 in 4 chance that he got the question correct. So the probability of success is equal to 1 in 4, or you could say 25%. So we know that both probabilities, the probability of success and the probability of failure, must equal 100%. So we know that if the probability of success is equal to 25%, then the probability of failure, or you could say the probability that a student got the question wrong, is equal to 75%. 25% plus 75% gives us a total probability of 100%. Okay, so now we have everything that we need to plug into our formula. And before I give you the formula, I'm just going to scroll down a little bit just to give myself a little bit more space. And the formula for binomial distribution looks much worse than it really is, so just bear with me. And basically, all this formula says is that the probability of any event x is equal to the total number of combinations, and I shortened combinations by just writing combos. So the probability is equal to the total number of combinations multiplied by the probability of success with a k in the exponent. K is just the total number of successes, all multiplied by the probability of failure with a n minus k in the exponent, and n minus k is just the total number of failures. Okay, so let's plug everything into our formula. We're trying to find the probability that the student got 4 questions correct. So the probability that a student got 4 questions correct is equal to the total number of combinations. And I'm going to talk about the combinations a little bit later, so I'm just going to leave that blank for now. And this is all multiplied by the probability of success, which we know the probability of success is equal to 25%, or you could say 0.25, with our number of successes k in the exponent, and we know that our k is equal to 4, so I'll put a 4 in the exponent. And this is all multiplied by the probability of failure, which we know the probability of failure is equal to 75%, or 0.75, with the number of failures in the exponent, n minus k. And we know that the number of failures is equal to 1, so I'm going to put that 1 in the exponent. So now let's go back to the first part of the formula and talk about the total number of combinations. We have to find the total number of combinations that a student can get 4 questions correct. So let's say he could get the first question incorrect, and the rest of the 4 he gets correct. The X means incorrect, and the O means correct. Or he could get the second question incorrect, and all the rest of them correct. He could get the third question incorrect, and all the rest of them correct. So on and so forth. Fourth question incorrect. And the last combination is if he gets the first 4 correct, and the last question he gets incorrect. So now let's count how many combinations we have. We have 1, 2, 3, 4, 5. We have 5 different combinations where the student gets 4 questions correct. So in our parentheses, our total number of combinations, we can put the number 5. And for the more difficult problems, it's much easier to find the total number of combinations using the formula n factorial, all divided by the number of successes, k factorial, multiplied by the number of failures, n minus k factorial. Once again, this is the formula for the total number of combinations. If we plugged everything into our formula, we have n, which is the number 5, so we have 5 factorial, all divided by the letter k, our number of successes, which is 4 factorial, all multiplied by our number of failures, which is 1 factorial. And if you don't know what factorial means, 5 factorial just means 5 times 4 times 3 times 2 times 1. This is all divided by 4 factorial, which is just 4 times 3 times 2 times 1, multiplied by 1 factorial, which is just 1. And if you plugged all this into your calculator, you would get our total number of combinations, which is 5. So going back to our original problem, we're finding the probability that a student got exactly 4 questions correct. So the probability that a student got 4 questions correct is equal to 5 multiplied by 0.25 with the 4 exponent, all multiplied by 0.75 with the 1 exponent. And if you plug that into your calculator, we get an answer rounded to 4 decimal points of 0.0146, or you could say 1.46%. So what is the probability that a student got exactly 4 questions correct? That is 1.46%. So I hope this gave you a better idea on binomial distribution and using that to find probability. There are a little bit more difficult examples, which I will make some more videos on, so stay tuned. So I really hope that you are enjoying these, and I will see you in my next one.